Hi, my name is Ko Jun Wei, and today I would like to talk about the characteristic of relational table. Each table row represents a single entity. Each table column represents an attribute. Each row and column represent a single data value. Each table must have an attribute or combination of attributes that uniquely identify each row. Next, I would like to talk about type of keys. Composite keys is a key that composed of more than one attribute. Primary key. Primary key is the key that uniquely identifies any given row. Super key. Super key is a key that uniquely identifies each entity in table. Candidate key, a super key without redundancies. Foreign key, an attribute in one table whose values must match the primary key in another table. Secondary key, a key used strictly for data retrieval purposes. Thank you.
Hi, my name is Teo Bong. I want to mention about what is dependencies. Dependencies is the role of key that based on the concept of determination, state in which knowing the value of one attribute is the basis for establishing the role of a key. If you know the value of attribute A, you can determine the value of attribute B. For example, student number and student name. After that, there are two dependencies in the database system. The first one is functional dependencies. An attribute is functionally dependent on another if can be determined by that attribute. There are two attributes in these dependencies. The first one is determinant, attribute whose value determines an others. The second one is dependent, attribute whose value is determined by the other attribute. The example of functional dependency is student number and student name to student GPA. The second dependency is full functional dependencies. Entire collection of attributes in the determinant is necessary for the relationship. The example of full functional dependency is student number to student GPA. Next, I want to talk about integrity rules. The first one is entity integrity. All primary keys entries are unique, and no part of a primary key may be null. Each row will have a unique identity, and foreign key values can properly reference primary key values. No invoice can have a duplicate number, nor it can be null. The second one is referential integrity. A foreign key may have either a null entry or an entry that matches a primary key value in a table to which is related. It is possible for an attribute not to have a corresponding value, but it is impossible to have an invalid entry. It is impossible to delete row in a table whose primary key has mandatory matching foreign key values in another table. Then I will show the example of entity integrity and referential integrity. Thank you.
Hi, my name is Lo Chiyuan. So I would like to talk about the ERD. The ERD, we all know that must have the entity, attribute, and the relationship. And the entity refers to the entity set and not a single entity occurrence, and it is participate in a relationship. And the attribute, it can be a primary key or also a foreign key, and it can be a value or left empty. Here is a very simple example showing us that the customer and the appointment are the entity, and the customer ID, first name, last name, appointment ID, appointment date, appointment time, all of that are the attribute. So the relationship are different two basic, that is change model and a crossword model, and it also describe to one to many, many to many, one-to-one relationship. So that's all for that. Thank you.
Hi, my name is Ong Bin Yu. Today I am going to talking about the example of one-to-many one-to-one and many-to-many. First is example of one-to-many. A customer can have many orders, but one orders can only has one customer. And the second one example is a team can have many members, but one members only can have one team. And this one is the chain notation, and this one is crossword notation. Next, I am going to talking about the many-to-many relationship. The first example is many lecturers can teach many students, and many students can teach by many lecturers. The second example is many students can take many subjects, and the subject can take by many students. Okay, the last one relationship is one-to-one relationship. The first one example is one people only can have one IC, and one IC only can belong to one people. The second example is a country only can have one president, and one president only can manage one country. Okay, thank you.
Hi, my name is Ting Dajian. I have already designed some simple business rule, which is each bus may be booked by many passengers, each passengers can book many buses, and each bus can stop many stations, each station can be stopped by many buses. And I have already designed Crawford ERD, and let me show you. And the relationship between the buses and passengers is many-to-many relationship. And one-to-one buses and buses may booked by many passengers, and passengers can book many buses. And the attribute of buses have bus ID, bus company, and the bus ID is the primary key. Attribute of passengers is bus ID, passengers ID, passenger name, passenger age, passenger gender, and passenger contact. And the passenger ID is primary key. And how to solve the many-to-many relationship is one-to-many, many-to-one relationship. And a bus, one-to-one bus has 0 or many tickets, and one-to-one passengers can book one-to-many tickets. And the composite entities which coded tickets, and the attribute of tickets is tickets ID, board time, board point, drop point, price, pass name, bus ID, and bus and passenger ID. And the primary key of the ticket is ticket ID. And at the many side, it must have foreign key, which come from buses and passengers. Only at many side got a foreign key, which is bus ID and passenger ID, which come from the primary key from the buses and passengers. So I will design another simple business rule. I will pass to my friend Desmond to explain about it. Thank you.
My name is Desmond Lee and I will explain about the relationship between buses and station. So the simple business rule is each bus can stop many stations and each station can be stopped by many buses. So this is the ER diagram that I designed. So the buses and station relationship is what many to many. Buses, I set bus ID as the primary key and bus plate, bus company, bus seat as the attribute as well. Next is station label. Station ID as the primary key and station name, station address as the attribute. So to solve this many-to-many relationship, we need to split it to one-to-many and many-to-one relationship. So now I will explain about how the many-to-many relationship work. So first, one buses has one-to-many seats and one station can drop one-to-many seats. So this seat table is the composite entity between the many-to-many relationship of buses and station. The next is we combine all the entity explained by Raje and me just now. So this is the conclusion. One-to-one passengers can purchase one-to-many tickets, while one-to-one buses has zero-to-many tickets, and one-to-one buses has one-to-many seats. Next, one-to-one station can drop one-to-many seats. Thank you.